Chi-squared test. A chi-squared test, also written as KH2 test, is a statistical hypothesis test that is valid to perform when the test statistic is chi-squared distributed under the null hypothesis, specifically Pearson's chi-squared test and variants thereof. Pearson's chi-squared test is used to determine whether there is a statistically significant difference between the expected frequencies and the observed frequencies in one or more categories of a contingency table. In the standard applications of this test, the observations are classified into mutually exclusive classes. If the null hypothesis that there are no differences between the classes in the population is true, the test statistic computed from the observations follows a KH2 frequency distribution. The purpose of the test is to evaluate how likely the observed frequencies would be assuming the null hypothesis is true. Test statistics that follow a KH2 distribution occur when the observations are independent. There are also KH2 tests for testing the null hypothesis of independence of a pair of random variables based on observations of the pairs. Chi-squared tests often refers to tests for which the distribution of the test statistic approaches the KH2 distribution asymptotically, meaning that the sampling distribution, if the null hypothesis is true of the test statistic, approximates a chi-squared distribution more and more closely as sample sizes increase. History. In the 19th century, statistical analytical methods were mainly applied in biological data analysis, and it was customary for researchers to assume that observations followed a normal distribution, such as Sir George Airy and Professor Merriman, whose works were criticized by Carl Pearson in his 1900 paper. At the end of the 19th century, Pearson noticed the existence of significant skewness within some biological observations. In order to model the observations regardless of being normal or skewed, Pearson, in a series of articles published from 1893 to 1916, devised the Pearson distribution, a family of continuous probability distributions, which includes the normal distribution and many skewed distributions, and proposed a method of statistics. Pearson's chi-squared tests, squared tests, squared tests, tests, squared tests, squared tests. Other examples of chi-squared tests. One test statistic that follows a chi-squared distribution exactly is the test that the variance of a normally distributed population has a given value based on a sample variance. Such tests are uncommon in practice because the true variance of the population is usually unknown. However, there are several statistical tests where the chi-squared distribution is approximately valid. Fisher's exact tests, SECT tests. For an exact test used in place of the 2x2 chi-squared test for independence, see Fisher's exact test. Binomial test. For an exact test used in place of the 2x1 chi-squared test for goodness of fit, see binomial test. Other chi-squared tests. Cochrane-Mantel-Heinzel chi-squared test. McNemar's test, used in certain 2x2 tables with pairing. Tukey's test of additivity. The portmanteau test in time series analysis, testing for the presence of autocorrelation. Likelihood ratio tests in general statistical modeling, for testing whether there is evidence of the need to move from a simple model to a more complicated one where the simple model is nested within the complicated one. Yates's correction for continuity. Chi-squared test for variance in a normal population. If a sample of size n is taken from a population having a normal distribution, then there is a result C distribution of the sample variance which allows a test to be made of whether the variance of the population has a predetermined value. For example, a manufacturing process might have been in stable condition for a long period, allowing a value for the variance to be determined essentially without error. Suppose that a variant of the process is being tested, giving rise to a small sample of end product items whose variation is to be tested. The test statistic T in this instance could be set to be the sum of squares about the sample mean, divided by the nominal value for the variance, i.e. the value to be tested as holding. Then, T has a chi-squared distribution within 1 degrees of freedom. For example, if the sample size is 21, the acceptance region for T with a significance level of 5% is between 9.59 and 34.17. Example chi-squared test for categorical data. Applications. In cryptanalysis, the chi-squared test is used to compare the distribution of plain text and possibly decrypted ciphertext. The lowest value of the test means that the decryption was successful with high probability. This method can be generalized for solving modern cryptographic problems. In bioinformatics, chi-squared test is used to compare the distribution of certain properties of genes, e.g., genomic content, mutation rate, interaction network clustering, etc., belonging to different categories, e.g., disease genes, essential genes, genes on a certain chromosome, etc.